Chapter 2, Lesson 4 of Advanced Algebra. We are now going to look at using these linear models that we've been working with in the last 3 lessons. And we're going to introduce, if you haven't seen them before, scatter plots and trend lines. And we're going to use these scatter plots and trend lines to help us interpret the real world data that we're looking at. And then we'll talk about how to use, how to problem solve, looking at word problems and looking at some things that we can use to help us get better at interpreting or solving those word problems. Now, a scatter plot, maybe you've heard this before, maybe not, but a scatter plot is just a graph that relates 2 sets of data. You have 2 sets of things you want to compare and see if there's a relationship between them. You can plot that data on a graph as an ordered pair, and then you can use the picture that you get from that to determine if there is a relationship between the 2 sets of data and how strong that relationship is. It's kind of a introduction to stats, so to speak. So a scatter plot might look something like this, where you take the 2 sets of data where you graph arm strength on one, a measurement of arm strength on one axis, grip strength on the other, and then you plot this data. And then we want to see, is there a relationship between arm strength and grip strength, and vice versa. So this is what a scatter plot looks like. As you can tell, it's a bunch of data kind of scattered, therefore scatter plot. Now once we've graphed this data, we want to look for a trend line or a line of best fit. And what we're looking for, or what this is called in mathematical terms, is called a regression. We're looking for maybe a line that fits the data, or it might be a quadratic, we'll look at those later this year, or a cubic, some kind of function that seems to fit the data the best. And then we want to calculate the equation of that line or curve, whatever it is, and that's called the regression. And what that regression line does is it approximates the data. All of the points on the scatter plot are not going to be on that line, but that line gets close to most of the data, so it gives us an approximation of the data and the relationship. The equation of the regression then, once we determine that, enables us to then predict what might happen in the future based upon the scatter plot that we have. And this is what we do, and this is how we analyze a lot of problems. So for instance, we have a couple of scatter plots here that I have. So we have this data that's plotted as a scatter plot, you'll notice, and then we have this line of best fit. It looks like these plots kind of are going up along this line, and you'll notice not all of these points are on the line. In fact, just a few of them are, but this would be the line where most of it is close to this line. This scatter plot over here, even though we have a line, you can tell these points are really far off. So what does that mean? Is there a relationship between these 2 pieces of data, or is there not? And we're going to use the scatter plot to help us determine that. So to create a scatter plot, what you're going to need to do is to identify what's going to be x and what's going to be y. Then you want to use a straight edge on your graph paper, and you want to draw a straight line and label each axis, one along the x, which is horizontal, one along the y, which is vertical. The y is always your dependent, that will be the vertical, and the horizontal will be your independent. It's very important that you identify a scale for each axis, because it's not necessarily true that the data has been measured with the same units, so you'll need to identify that on each of your axes. Then you want to go ahead and plot the data, and then you'll draw that regression line, and then we'll teach how to calculate that with a calculator. Now, the application of the scatter plot would be that we want to draw this line as best fit, and then we want to determine the equation of that line, because once we have the equation, we can then substitute in different x values and figure out what the y values would be in the future that are off the table. So your scatter plots should look very much like this. Now, we can interpret the strength of the scatter plot. A positive slope, meaning the line goes up from left to right, means there is a positive correlation between the 2 sets of data. A negative slope means there's a negative correlation between the 2 sets of data. That means the line is going down from left to right. Now, a strong correlation would be where most of the points are very close to the trend line. So the closer the data is to the trend line, the stronger the correlation between the 2 sets of data. A weak correlation, they'd be further apart or further away from the trend line. So you can see these points here, we could draw a line that goes right up here, So it's going up, so there's a positive correlation here. But even though if we were to draw a line, they wouldn't all be very close to that line, so it would be weak. Here we draw a line, you'll notice that the points are closer together, so this is a stronger relationship. And then again, going down, seems to be a correlation going down here, but again, the points aren't real close together, so it would be a weak correlation. This is stronger. And over here you have points scattered that all over the place, and there isn't really a line that we could draw that really has any kind of correlation here. So this would be a set of data that has no correlation. One is not related to the other at all. So that's a quick overview of scatter plots, how to make them, how to interpret them. In the next lesson we'll talk about interpreting data and how to some tips to problem solving when you're working with word problems.